get to my okay, what do we have here? Okay, assignment. The topic is logarithms. 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 Logs. It's page 262, 3 through 57, every other odd. Every other odd. So go ahead and write that down. Put your name, date, period on the right. Okay, so what is a logarithm? I'm assuming that you guys have never seen a logarithm. I mean, you've seen them, but you've never really been taught about them, but maybe you have. I don't think you have. Let's take a problem that looks like this. 7 raised to the x power equals 49. Now, what does x equal there? You don't need to write it down, but I'm just asking you, what does x equal? Because I'm trying to explain what logarithms are for. So this is an example of why we would use logarithms. But we don't really know. But what is x equal to? Let's go with what is x equal to? Abraham, what is x equal to there?
2.
X is equal to 2 because 7 to the second power is 49, which we have right there. And we could say x equals 2. You don't need to write this down. You can if you want. But what about this? What if I say 7 raised to the x power equals 40? What is x going to be equal to there? Exact numbers, please, Alonzo. What is x going to be equal to? 7 to what power equals 40?
Maybe like 1 point something.
I want exact.
Okay.
Do you know?
No.
Neither do I. I don't know either. Okay? And that's where we have no way of solving this algebraically. We cannot do it. We don't know how to do it yet, except for logarithms. Okay, so now write this down. So if we look at this, write this down. 7x equals 40. The 7 is called the base. Write that down. The 7 is the base. The x right here is the exponent, and this is what it's equal to. Okay? The product, I guess. It's equal to that. Now, this is this. I can write this. This is exponential form. This is logarithmic form. Log form. Log. Actually, no, this doesn't equal this. This equals this right here. But write this here. This equals, sorry, this equals this. But write this down. Log. Now we have a little tiny b here. This is the base. Okay. The base, remember, is this number right here, the 7. But the way we write it, it has to be a little bit lower and a little b. Okay. If you write it the same, I'm going to mark it wrong. Or, if I was grading a handwritten test, I would mark it wrong. You make a little b, a little bit lower, and then you write a regular x, That is the equals. That's the 40. And here is the exponent. It's all equal to the exponent, is the y. Okay, so this is the base, this is the equals, and this is the exponent. So, to write this in log form, I want you to write this down. Log, low 7 is the base. 40, you put the 40 here, and then the exponent right there. And that's how you write that in log form. Now I'm going to show you a little trick so it's easier to see, but make sure you write that down at least. Okay, any questions so far? And here's another way, I have it written down here. So the way to help us write this is, I'm going to write it out twice. So here, I'll write it right here. Watch how I write this, because I think sometimes it's easier when the teacher writes it. 7x equals 40. That's exponential form. Now to write it in log form, you write the word log, little 7. First you do the base. Base here. And then you take the x and the 40. And guess what I do? I'm going to switch them. Bloop. So I'm going to switch it. Instead of writing 7 raised to the x, I write log base 7 40 equals x. You switch them. Okay? Just switch them. As long as you have the x on the right. Okay. So let's get to work. Let's get to the problems. Are you guys ready? Here we go. Okay, number 3 is kind of weird, so I'm going to show you what the answer is, and I'll explain it later on, because I need a problem to show you how to do this, and we'll get back to 3. So number 3, we have two relationships, y equals 7x, and y equals log 7 to the x. Okay, actually, you know what? I'm going to show you guys. Can you guys see here? There's 3. Go ahead and write that down. Let's write them like this. So we're used to seeing our logs. 7x equals y. And I've been teaching you, so it looks like this. Let's put in the form that we're used to seeing for now. You don't need to. You've seen it that way, right? Now, let's switch the x and the y and make this 7y equals x. We are solving for the inverse. Let's write in log form. Log base 7. And then switch the x and the y. And I got x equals y. So what did I do there? I switch the x and the y, and then I solve for y in log form. So guess what? These are inverses. Now, you might be confused by what I said there. I'll show you in just a second what I mean in another problem. But just write down what I have there and just say that they're inverses for now. Say that they're inverses for now. We'll get more in depth in that in just a second. But what did I do? I wrote it like, I just wrote like, so we're used to seeing it this way. I switched the x and the y, and I basically solved for y by putting in log form. And then those are inverses. Those are inverses, okay? They are inverses of each other. Are there any questions? We're doing every other odd. Okay, so sorry, I have to handle parenting stuff there. Okay, so let's go on to what has 3. I think we're on 7 next. Okay, rewrite the equation in exponential form. So we kind of did that already, so let's go ahead and do it again. 7, exponential form will look like this. Log 6 to the 1 equals 0. So let's write this in exponential form and see if it makes sense. Log 6 to the 1. Hey, I'll give you guys like 10 seconds to do it yourself. Go ahead, you guys go ahead and try to solve that yourself. Okay, I'm going to call on one of you. Here we go. Okay, let's go with Angel Lopez. What'd you get, Angel Lopez?
I got 6 for the base. That's it.
Okay, cool. That's good. You're doing good, Angel. Stay with me. Keep your microphone on. Your microphone's still on?
Yeah.
Okay. So now remember, as long as the equals on this side, all you got to go do is go like this. See the 1 and the 0? Can you see my pens? You just go flink, and you switch them. So instead of 6, 1, 0, you go 6, 0 equals 1. Okay? Anyway, thank you so much, Angel. That's it. And does it make sense? Is 6 raised to the 0 power equal to 1? Yes, it does. So let's skip 9 and go to 11. Actually, do we need to do 11? 11 is kind of the same thing. So just do that for 11. I think, is 11 the same? No, 11 is different. Rewrite the equation. Now I got to write in log form. Okay, so now they give an exponential form. 6 squared equals 36. Okay, so now let's write it in log form. So you guys do that, okay? You guys do that. I'll get you started. We're going to say, I'll get you started. Log 6, okay? Because that's the base. Now remember, switch the 36 and the 2. Make sure the 6 is a little tiny 6 that's low subscript kind of thing. You know what I mean? Little tiny. Okay, so let's see. Let's go with All right, Brett, what do you got? What's it equal to? Log 6 what?
Log 636 equals 2.
Perfect. Remember, we just switched the 36 and the 2, and those are equal to each other. Okay, so that's all you have to do for those. 11, 13, I think 15 is, let me know if I'm messing up on my every other odds. I always get messed up. I think 15 is next. I don't know if we need to do 15. Alonzo, is 15 next?
Unless you want to do 13. Yeah, I think it's 15.
Yeah, I'm doing every other odd.
Yeah.
Okay, actually, you guys do 15 on your own. You just have a fraction there, but just go ahead and do that one. Now let's go to 19. I'm at 19. They say evaluate. Now this is on your check your understandings that you have to do. Log 3 to the 3. What does that equal? Okay. Log 3 to the 3. What does that equal? Okay. So let's put a question mark. How do we solve this? Well, the idea is let's put it in exponential form. Okay, so log base 3, and then we switch the 3 and the question mark, where the question mark goes here, and is that equal to 3? So what does this have to be in order for it to be equal to 3? What does the question mark have to be? All right, what does that have to be? What does it have to be? Let's go with Connor. Go ahead, Connor. What should it be?
1.
1. 3 of the 1 is 1, so your answer is 1. That's all you do. Your answer is 1. This is equal to 1. We just saw that question mark has to be 1, so that's 1. 3 log base 3 is equal to 1. So that's how you solve it. You put an exponential form and just solve it. 19, 21, 23 is next. Every other odd. You guys, well, I'll do 20. I'll help you with 23 too. Because we got a decimal there. Log 4 to the 0.25. What does that equal? Put a question mark. Okay. You guys have that written? So write that in exponential form. Go ahead and write that in exponential form. Write that in exponential form. Tell me what it is in exponential form. I'm going to call on one of you. Here we go. Actually, I'll wait. I'm waiting. Not anymore. Emma, write this in exponential form, Emma.
4 with a little
Very
question mark for the exponent equals 0.25.
Great. Now, what should that be? Let's write it this way because I'm confused by the way that looks. So let's write it this way. 4 to the what equals 0.25? How do I make this equal 1/4? Or 1 over 4 to the 1 power? What should this equal? Should I call on someone or someone yell it out before I call on someone? Anyone know? All right, Ian. What do you think?
I'm not sure.
Did you say -1?
-1.
Yes, because to the negative, remember we write to the negative power. It's the same as writing it as a positive in the denominator, right? So it's -1. Anyway, that's why I want to show you that. So to fix it, change it to a fraction, and then you do the negative exponent. All right. What are we at? So that was 23, 25, 27. Okay. Evaluate the logarithm using a calculator. Okay, so now we can use everyone get their scientific calculators. I'll give you guys like a minute to get your scientific calculators. Give you a minute to get your scientific calculators. And if you don't have it, write this down. Log 6. Okay. Now, a couple things I want to show you here. Let's see who's getting their calculators. Who's getting their scientific calculators? All right, Connor's getting it. Let's see. Emma, do you have your scientific calculator?
Yeah.
All right, show it to me. Let's see. Thomas, do you have yours? Scientific calculator?
Yeah.
Show it to me. I don't believe you. Okay, you got a graphing calculator. Very good. Thank you, Emma. Dennis, show me your calculator. Yes, prepared. Lorenzo, show me it.
I have to go find it.
Go. What do you mean? Is it like, will it take you more than a minute?
No, it's because it's from last year and it's still in my old backpack. I have to look for it.
Will it take you a minute to find it?
Yeah, I could probably use one from online though. So
Get your one from your backpack if it takes you a minute. If it takes longer than a minute, don't get it.
no, because I have to look for my backpack too.
So it'll take more than a minute, is what you're saying.
Yes, I'll just look for one online. There's probably an online one I can use.
I know, but okay. I thought you said it would take less than a minute. But if it takes more than a minute, that's fine. Carlos, show me your calculator.
It's not with me.
Where is it?
It's in my backpack somewhere.
Will it take you more than a minute to find?
Mm-hmm.
Like Lorenzo?
Yep.
Where's your backpack?
In my room somewhere, I think.
Okay, so you have to find the backpack then. That sounds like a lot of work. Nathaniel, let me see your calculator. All right. Miley, let me see it.
I don't have it with me.
Where is it?
I left it at my grandma's house when I took it one time.
Because does your grandma, she's probably using it. Is she doing Math 3 honors too?
No.
Oh, okay. Never mind. That's fine. All right. Let's go. So what you guys must know is notice, let's look at all these log problems here. If I see here, look at 27. See how there's no base? But all these have bases. Log base 4, log base 7, log base 3, log base 1/2, log base 6, log base 3. They all have bases. I know you're probably getting sick. I'm just flashing through. But, okay, now I'm lost. Oh, okay. So, but look at 27. It does not have a base. No base. Look at 28. No base. No base. No base. No base. If there's no base for a log, that means it's a log base 10. If there's no base of a natural log, LN stands for natural log. It is log base E. What the heck are you talking about, Sensei? So log, just let's say log 6 is really equal to log base 10/6. Okay? So that's what that is. It's just a log base 10. It's kind of like how, they say x equals 1x. Now I'm looking up E as a number. E, because I have to remember. Okay. E, natural log, let's say over here, the natural log of 5. There's no base. This is the natural log, is really like saying, it's just saying log base E to the 5. Now you're saying, Sensei, what the heck is E? E is just a number. You guys know how like pi is a number, 3.1416. E is a number, 2.718. And it goes on forever. So it's really like saying natural log 5 is like saying natural log or log base 2.718 to the 5. But you don't really need to know that. All you need to know, really, regarding 27, when they want us to solve for the log base 6, is you just go on your calculator and you look at your calculator, and this, I don't know if you guys, can you guys see my calculator there? This log is a log base 10 in your calculator. In your calculator, it's a log base 10. The natural log is this, the ln. That's a log base e. So all you do is just go like this. Log 6 for log base 6 is just, for log base 6, just log 6, then hit enter. And I get 0.77815. That's all you got to do. Just punch it in the calculator. Punch it in. 27, 29, 31 is next. Are there any questions on that? So let's do 31. Was that too fast? Let me know if I need to go back, because I'm kind of going.
What does
3 times the net. Wait, what's that?
What does 1n stand for? Or is it
1n. Which one?
Or what is
Oh, this is ln.
Oh, ln.
It's just natural log. So all that is, that's what I was trying to show you here. ln, that's an L. If you're confused by my handwriting, just like log with nothing 6 is log base 10 6. Natural log 5 is really, this is what this is. It is the log with the base of e to the 5. And all e is just a number. But you don't have to worry about that. You just have to know it's the ln button on your calculator. If that's confusing, let's do this one, and this is all you really need to know about this. To calculate this on your calculator, the natural 3 times the natural log of 0.5. Let's first go, it's 3 times the natural log of 0.5. Let's first find the natural log of 0.5. All you need to know is on your calculator, the natural log is this button right here. This button right here, okay? So let's find the natural log of 0.5. Then I get negative 6.93, negative 0.693. And then let's multiply that. Then we multiply it times 3. And I get negative 2.7944. And that's all you got to do. Just punch it in the calculator. I think it's easier instead of doing it on your computer. At least if you guys have the calculator, you just punch it on the calculator. First of all, the keys are easier to punch than your phone, in my opinion. Secondly, at least you don't have to keep opening up different screens in your computer. It's easier to just stay on one screen. But anyway, that's your answer. Are there any questions on 31? I'm trying to make it so you can see everything. Any questions on 31? 31, 33, 35. 35 is next. No questions? I'm sorry. Did I go too fast? I'm gonna leave this here for 10 more seconds unless someone needs it. Going to 35. Okay. Simplify the expression. Okay. Couple things here. If you look at this, 35, let's write it in Let's write 35 in exponential form. 7 log, my exponent is log 7 to the x. Okay, so let's think about this. Let's write an exponential form. Okay, so I'm sorry, no. Let's write it in log form. It's an exponential form. Just my exponent is my exponent is a log. So this is in exponential form. Let's write it in log form. So what does that equal, right? So let's write it in log form. So it's log base 7. Can you guys see that there? Let me scoot it up. Now remember, we switch these. Question mark equals log 7 to the x. So my question to you is this. What do I need to change this question mark in order for it to be equal to this side? Everything else is the same. So what should the question mark equal? Should equal x. So what's going on here? If I have a base raised to the log base, okay, which is the same, as long as these bases are the same, guess what? It's always going to be equal to this number here. So if I did this, let's do another one. So you can see another example to see this pattern that happens. If I have 5 log 5, and then let's say this is, I don't know, let's just put number 12 there, okay? Guess what this is equal to? Because this is 5 and this is log base 5, this is all going to be equal to this number here, which is 12. You can copy this down if it helps you. I'll leave this there for a second. That's just an example. Here's the rule. I'm going to get rid of this in 10 seconds unless someone needs it. Here's the rule. Write this down. 5, 4, 3, 2, 1. Here's the rule. Right here. Here's the rule. Write this down. This rule is what we talked about. As long as the base and log base is the same, it's going to be equal to x. The log base is the exponent. Now, also, this rule here, so write this rule down. And then write this rule down here. Log base b to the x equals x. As long as the base and the equal has an exponent of an x, then this will also be x, okay? As long as the base and this base is the same, then they'll both be equal to x. Okay, so go ahead and write that down. Hang on, I got to do some parenting real quick. As you guys are writing that down, let me do some parenting. I'm gonna yell at my kids, so I'm gonna mute my microphone. All right, I'm back. Sorry. I let my kids get my kids back into shape. So those are the rules. I hope you have the.
Excuse me.
Yeah.
You said that there was 3 that we needed to copy, right? Or just 2?
Just 2. This one here. And this one here.
Okay.
This is called the power of a power property. Power of a power. Power of a power. Okay, so we're on 39, no, wait, 35, 37, 39, I think was what we're on. So, same thing here. The power of a power is what this one is, 39. The power of a power. So I have log 3, and then I have 3 to the 2x. Notice how they're both 3's. So this is going to be equal to 2x. 3 raised to the 2x equals to 2x. Exponent's going to be the same. And if we wrote an exponential form, it look like this. 3, and then we switch this. 3 to the question mark, which I don't know what it is equal to 3 to the 2x. Well, we said this has to be 2x in order for that to be 2x, so that's what we do. Anyway, that's 39. The answer is this is 2x. The answer is 2x. 43 is next. 43. Okay, so this is where we're talking about the inverses. Remember we talked about the inverse? So here's an example. When I showed you that number 3 that was the inverse, this is what we were doing. Okay, so it says solve for the inverse. Y equals 0.3 to the x. Okay, now let's put it the way we are used to seeing it. This is 43. We're used to seeing it like this. 0.3 to the x equals y. Okay. So let's solve for the inverse. The inverse, you switch the x and the y. Right? And then you solve for y. Now, we don't know how to get y by itself if it's in the exponent. However, we do know how to get y by itself if we write it as a logarithm. So let's write it as a logarithm, right? So we go log. We know the base is 0.3. And then you switch the x and the y. X, y. So x equals y. And so we can write it as the inverse of this is y equals log 0.3 to the x. Are there any questions on that? So we did what we did before. The inverse, you just switch the x and the y and solve for y. The way we solve for y is you use log mode. Put in log form. To do the inverse, we switch the x and the y. And then to solve for y, we put it in log form. That's that. Okay, that was 43. So 47 will be next. Do the same thing with 47. Well, I'll do 47 with you. Because 47 is a natural log. So y equals natural log of x minus 1. So natural log. Let's write it this way. Natural log of x minus 1 equals y. We're used to seeing it that way, right? Now, just so we can understand it better, let's write it with the log base e. Remember, the natural log is a log base e. So I can write this as log base e, which is just a number, 2.71 or something like that, times x minus 1 equals y. Now, we got that. Now, what do we need to do to solve for the inverse? What's the first step that we do to solve for an inverse? Then we have all that. Let's just do what we know, okay? What's the first step that we do to solve for the inverse? Let's go with Dennis. What's the first thing I'm going to do to solve for the inverse?
I forgot.
What did you say?
I forgot.
You said switch the x and the y?
Oh, yeah, that's what I said.
Switch the x and the y. And then we solve for y. So the y is all in there, but don't worry. Let's just put in log form and see what happens. Or let's put in exponential form and see what happens. Log base e, switch the x and the y, raised to the x equals y minus 1. Okay, so far so good. Is the y by itself yet, though? What do I need to do to get the y by itself? Julissa, what do I need to get the y by itself now?
You add 1 to both sides.
Let's do it. Flinky, flinky. We got this weird e plus raised to the x equals y. So the inverse is y equals e to the x plus 1. And that's all you got to do. So what did I do there? Remember, you got to switch the x and the y to get the inverse, right? We also know that's natural log, which is just a sexy way of saying log base e times x minus 1 equals y, right? I switched it around. Then we just solve for y. We put it in exponential form, which we learned how to do. And then this minus 1 here, you just add 1 on both sides, and boom. That's the inverse. Are there any questions? Okay. That's 47, 49, 51 is next. I'm like doing all your homework for you. I'm like too nice of a teacher. 51 is the same thing. Figure out 51 for yourself. Do 51 on your own. So 55 is the last one that we're going to do. Graph the function. Okay, you need graph paper for this. This is why I'm presenting here, because we need graph paper for this one thing. Now, how the heck do you graph a logarithmic function? How the heck do you graph a logarithmic function? Okay, so there you go. How do you graph that? You put it in exponential form so that we can see it. Let's put it in exponential form, okay? So why don't you guys go and put that in exponential form for me? Put it in exponential form. I'm going to call on one of you. Put it in exponential form. Remember, it might be easier to look at in this, put the y on the right. That might be easier for you. It's easier for me. All right, Nathaniel, give it to me. What did you get?
4y equals x.
Very good. Any questions? Very good, Nathaniel. Now, I'm going to write it like this, equals 4 to the y. Normally, we plug in an x and solve for a y, but the y is now an exponent. So guess what? We're going to switch it up a bit here. We're going to plug in y and solve for x. So let's make a chart. Make a chart with me. Make a chart. Now, let's plug in y and solve for x. So, any numbers, but let's just go with -2, -1, 0, 1, and 2. Plug those numbers in for y. Need negatives and positives so we get a good picture. So all we're doing is we're just kind of doing everything backwards because logarithms are kind of inverse of exponents. So let's go ahead and solve it. Let's do first 4, right? Plug in -2 for y. What is 4 to the -2? What is 4 to the -2? Let's go with, all right, Miley, see when you get back. Billy, what's 4 to the -2?
I don't know.
Did you say, Billy, did you say 1/4 to the +2?
Yeah, that's what I said.
And did you say which is equal to 1/16?
Yeah.
Okay, Billy, stay with me then. Let's plug in -1. So what is 4 to the -1? Based on what you just told me before, what is 4 to the -1 equal to?
1/4 to the first power.
Which is just 1/4, right?
Yeah.
Very good. Okay, so now let's do 4 to the 0. 4 to the 0, plug in 0. So now I'm solving for my x. I got 1/4 for my x. What is 4 to the 0 power? Naveed, what is 4 to the 0 power?
1.
Very good. 4 to the 1 is 4, and 4 to the 2 is 16. I'm not even going to write that out. So now you just plot your points. Okay, so let's make our coordinate plane. You all make your coordinate plane with me. How are we doing on time? Almost out of here. Tomorrow we're doing a lesson 2. We are also doing a lesson since we already took a test, so we'll get ready to take notes tomorrow. Tomorrow is a whatchamacallit day. I don't know. Late start. This COVID thing is so weird, man. So weird. Okay. So let's plug in our points. X is 1/16. Y is -2. What the heck? 1/16. That means 1/16 of all this is just, we just go over a little bit and down -2. We get a point right about there. I don't know, it just has to be approximate. X is 1/4. Y is -1, so it'll be right about here, right? 1/4, go over 1/4, go down -1. Get that point right there. X is 1, y is 0, right? X is 1, 2, 3, 4, y is 1. And then 16, 2, I can't fit that. But let's connect the points. Now, it's always going to be, for logarithm, you want to get as close to that y-axis as possible, and then hit the curve, and then you're going to shoot out that way. It'll look and go up gradually, and just draw your arrows, and there's your logarithmic function. That's what it's going to look like. Dun 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 dun. Dun 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 dun. Okay, are there any other questions? Are there any questions on that? I'm gonna get rid of this in 10 seconds. Alonzo,
Yeah.
did you learn anything today?
Yeah, a good amount. It's a
Good,
lot.
a lot went on, huh? You can watch the
Yeah.
video and record this. How about you, Thomas? Did you learn anything today?
Yeah, I learned a lot.
All right. What about you, Sam? Samuel? Samuel, are you there?
Yeah, I'm here. What's up?
Did you learn anything today?
Yes, I did.
All right. Ethan, Ezekiel.
Yeah, I learned something.
Okay. Here's what I want you all to do. Everyone in the chat, type in "Bye Sensei." Just type it in. Don't enter it yet. Just type it in. Don't enter it. It is all typed in. Julissa, do you have it typed in?
Yeah.
Okay. Nathaniel, do you have it typed in?
Yeah.
Okay. Mara, is it typed in?
Yeah, it's typed in.
Okay. Okay, I'm going to dismiss you guys, but not yet. I want you all to hit Bye Sensei at the same time. I want to see if we can make the computer explode, okay? When I count to 3, and then once you hit it, you can go ahead and go. Ready? 1, 2, 3. Hit it. Whoa, my computer's exploding. Oh my gosh, it all just happened at once. You guys can go. I'll see you tomorrow.
I didn't have time to copy down 39 all the way.
Alrighty.
Oh, sorry about bashing into crashing into your period
Oh,
3
it's fine.
class.
I just it threw me off. I thought I lost. I'm wait a minute. Wasn't sure what was going on with my time and
Yeah, I thought my class was starting already. So, and I was just like looking like, hey, wait, I don't remember Micah being in my class.
Oh, you know Micah?
Yeah.
How do you know him? From math too?
Middle school actually. Yes.
Oh, okay. He's a funny guy.
It's been a while since I spoke with him. All right.
There's 39.
All right, thank you. I just like needed like the 2 ats like on top of the 3.
Yeah, okay. Sorry, stop me if I go too fast. I know you're good at that though, so. Is that it?
Mm-hmm.
Alrighty.
All right. Well, have a good day.
Okay, Abraham, take care.